14 hours, September 4th. The cloud deck at 5,000 feet tears open as two Venezuelan F-16s drop into the humid air. They are executing a classic hook attack. The lead pilot flips his jet inverted, hauling back on the stick. His analog airspeed indicator, technology dating back to 1983, spins past 550 knots as he dives on the stern of the USS Jason Dunham. His wingman brakes left, screaming toward the water to split the target's attention. Two jets, two angles, one ship. It's a textbook bracket maneuver. The only problem? These pilots are flying jets that were considered cutting edge when Top Gun was in theaters, the first one, and this isn't 1986. On the deck of the destroyer, the Phalanx CIWS close-in weapon system snaps awake. Its white radar dome locks onto the lead jet instantly, while the aft mount tracks the wingman. The 6 barrels begin their pre-spin whine, ready to vomit 4,500 tungsten rounds per minute. Inside the Combat Information Center, the mood is board efficiency. The massive SPY-1 radar isn't just tracking the jets, it's reading their biography. The radar pulses hit the airframes 30 times every second. The fire control team has a firing solution before the pilots even level out. The lead F-16 bottoms out at 500 feet, afterburners glowing. The pilot thumbs his weapon selector to heat. He's carrying the IM-9L Sidewinder. The missile's infrared eye spins, hunting for a heat source in the 3 to 5 micron wavelength. He waits for the growl of a lock tone. Silence. The missile is confused. It was built to hunt jet exhaust burning at 1,000 degrees Celsius. The destroyer's smokestacks are emitting heat at 200 degrees in the 8 to 12 micron range. To the Sidewinder, the ship is invisible. And even if it could lock, the IM-9L has a pathetic 11-mile range. Modern US jets use the IM-9X, which can lock onto targets behind the pilot. These Venezuelan relics have to point their nose directly at the target, like it's a World War II dogfight.
The wingman is down at 50 feet, salt spray caking his canopy. He is flying on instinct because his radar altimeter is dead. It's a known glitch in these older models that cuts out below 500 feet, a problem Venezuela can't fix because they can't buy, steal, or manufacture the spare parts. He pulls up to 100 feet and immediately gets painted by 3 different tracking radars. His AN/ALR-69 warning receiver screams, but only in the front. The sensors on his rear left quadrant are corroded from water damage, leaving him completely blind in that direction. The rear right sensor is flickering. He is flying a museum piece into a digital kill zone. This is the nightmare of taking a Block 15 F-16 against an Aegis destroyer. No targeting pods, no laser-guided bombs, no GPS integration, no JDAM satellite-guided munitions. Their 1980s mission computer barely has the processing power of a calculator. They have no Harpoon anti-ship missiles, no HARM missiles to kill the ship's radar. Their entire plan is to strafe a heavily armored warship with a 20mm cannon and heat-seeking missiles that can't see ships. A modern F-16 would carry the LRASM, a stealthy AI-driven cruise missile that can pick out a specific ship from 200 miles away. These Venezuelan pilots are trying to sink a Death Star with a revolver. They are using tactics that died decades ago. It's the same profile the Argentine Air Force used to sink the HMS Sheffield in the Falklands War. Fly low, pop up, shoot. But the Sheffield had a radar that took 20 seconds to spin around. The Jason Dunham's SPY-1 radar watches everywhere, all at once, updating 30 times a second. The lead pilot tries to lock the ship with his APG-66 radar for a gun run. The mechanical antenna sweeps back and forth like a slow metronome, 3 seconds per sweep. He switches to track mode. The radar goes blind. In these old jets, you can search or track. You can't do both. Worse, at 200 feet, the radar is blinded by sea clutter. The waves look like mountains to the ancient processor. The pilot is frantically twisting gain knobs, trying to find a 500-foot steel ship in an ocean of static, while flying 580 knots just above the water. The lead pilot aborts the run, pulling up to 1,000 meters. His fuel gauge, assuming the sensor isn't lying, reads 4,200 pounds. 3 minutes of afterburner just drank 2,400 pounds of gas. The wingman joins up. They don't have Link 16 data links to share information silently. They have to use hand signals. 5 fingers, twice. 5,500 pounds remaining. US jets share a digital consciousness. These guys are communicating like it's 1945. They split for another attack. Lead takes the bow, wingman takes the stern. They think they are dividing the enemy's fire. They are wrong. The Aegis system can track and kill 18 targets simultaneously without breaking a sweat. The ship's electronic warfare officer flips a single switch on the SLQ-32 console. The jamming begins. The Venezuelan radars operate on a fixed 9.3 gigahertz frequency. They can't hop frequencies to avoid jamming. Suddenly, the lead pilot sees 3 destroyers on his scope, then 5, then 1, then nothing. The wingman sees the ship split into 2 ghosts moving at impossible speeds. They are hallucinating electronically. The lead pilot pushes his jet past 550 knots in a dive. The F-16 shudders violently. This isn't turbulence, it's the airframe screaming. 40 years of dubious maintenance, 40 years of duct tape and prayers. The metal fatigue is critical. Something cracks behind the cockpit. Hydraulic pressure starts to wobble as old seals give way. The flight control computer is struggling to keep the jet flying straight. A modern F-16 has quadruple redundant digital controls. This jet has dual redundant analog circuits, and redundant is a strong word for systems this old.
On the ship, the crew is placing bets. The CIWS computer has already calculated the kill chain. 1.3 seconds of fire, 97 rounds expended, intersection point calculated to the 7-meter. Meanwhile, the ship's radar puts 1 megawatt of energy onto the jet. That's enough electromagnetic power to fry the F-16's overloaded electrical generators. The pilots are unknowingly teaching a masterclass titled How to Die in a Modern War. They thunder over the ship at 300 feet, accomplishing nothing but turning fuel into noise. They turn south, radios crackling on unencrypted channels that any baby monitor could pick up. The U.S. Navy intelligence team records every frequency, every emission, every mistake. Tomorrow, the pilots will be ordered to do it again. 14:30 hours, September 5th. The same exhausted pilots strap into the same dying jets. Commanders have screamed at them. The president has screamed at the commanders. The order is clear. Be aggressive. Get good footage for TV. They run pre-flight checks. The lead jet's navigation system shows their position is 20 miles away from where they actually are. It hasn't been calibrated since 2006. The wingman's radar warning receiver is totally dead on the left side. They are launching broken arrows. As the lead jet climbs past 10,000 feet, bang! It sounds like a shotgun blast in the cockpit. Compressor stall. The pilot shoves the nose down to force air into the intake. The engine catches with a sickening shudder. The Pratt & Whitney F-100 engine needs an overhaul every 4,000 hours. This one is likely run for 6,800. The blades are cracked. If he turns too hard, the engine dies. He is flying a fighter that can't fight. They think they're alone. They aren't. An E-2D Hawkeye radar plane saw them take off from 200 miles away. A Virginia-class submarine is listening to their comms. High above, an MQ-4C Triton drone is streaming 4K thermal video directly to the Pentagon. Admirals are watching this live, eating popcorn. The Venezuelan pilots are handing out free intelligence data like flyers on a street corner. The lead pilot rolls inverted at 12,000 feet, a 60-degree dive. Without a targeting pod, he has no laser guidance. He is aiming using a fixed crosshair projected on the glass, technology that hasn't changed since Vietnam. A modern jet would use a sniper pod to guide a bomb through a specific window from miles away. This guy is guessing the math while plummeting toward the ocean. The wingman is down on the deck again, trusting a broken radar altimeter. Salt water is seeping through his canopy seals, dripping onto the electronics. His radar is useless. Modern AESA radars can map the ground through clouds. His radar can't tell the difference between a wave and a warship. The destroyer decides to play games. The electronic warfare suite inserts phantom targets. The lead pilot's radar shows the ship 30 degrees to his left. He turns to attack. Empty water. The wingman sees 5 destroyers surrounding him. Modern U.S. jets carry jamming pods to fight this. These jets are naked. At 3,000 feet, the lead pilot realizes the radar is lying. The ship is 500 meters to his right. He yanks the stick. 5 Gs. His G-suit, which has been leaking since 2019, fails to inflate. Blood drains from his brain. His vision tunnels down to a tiny straw. For 2 seconds, he is unconscious, hurtling at 400 knots just above the waves. He wakes up at 1,500 feet, disoriented, tasting the copper tang of fear. The wingman tries a slashing attack. The destroyer's phalanx gun elevates its barrels. It doesn't shoot. It just spins up the barrels to let the pilot hear the sound of his own death. But the gun doesn't need to fire. The maintenance crew already killed this jet. The port generator is running at 60% capacity. The wiring insulation has rotted away. As he dives, the ship's radar switches to high power track. 6 megawatts of energy slam into the jet. The aircraft's systems go haywire. The artificial horizon tumbles. The compass spins like a slot machine. The fuel gauge flickers from empty to full. The electromagnetic interference is literally scrambling the jet's brain. The lead pilot makes one last desperate pass. 14:49 hours. He pushes the throttle to full afterburner. Boom! The compressor stalls again. This time it doesn't clear. The engine is done.
6,800 hours of abuse have finally collected the debt. The jet yaws violently as asymmetric thrust kicks in. He pulls the throttle to idle, trading speed for life. He is now gliding toward a hostile destroyer at 300 knots with a dying engine. On the destroyer's thermal cameras, the F-16's engine is glowing white-hot, 200 degrees above the safety limit. It is cooking itself from the inside out. The phalanx operator has the firing solution locked. One button press and the jet becomes a cloud of aluminum confetti. He holds fire. There's no need. The jets limp home. They burn 14,000 pounds of fuel, their entire monthly training allocation, to achieve nothing. The destroyer sails on, its paint scratched only by the salt air. The lead pilot's engine dies completely as he crosses the coast. He manages a dead-stick landing at Barcelona Airport. The wingman lands with 300 pounds of fuel left, about 90 seconds from falling out of the sky. The Pentagon's response? They deploy 10 F-35 Lightning II stealth fighters to Puerto Rico, not because they need them, but to send a message. Against these Venezuelan relics, it wasn't a fight. It was like bringing a Formula One car to a race against a shopping cart missing 2 wheels. Bye for now. If you like deep dive and military, please don't forget like, comment, share, and subscribe for more informative videos. Thanks for watching.